Hey everyone, Mr. Aaron's again. Today we're going to be talking about simplifying algebraic expressions. We're going to dive right in. I'm going to try to keep it as short as I can because this lesson is a little bit longer. So the first thing I want to talk about is algebraic expressions. What are they? We talked about this before. Three main components of algebraic expression. They have a variable, that's a letter. A number, you know what a number is. And an operation symbol, plus, minus, divide, times. So those three things make up an algebraic expression. Could look something like this. Could look something like that. I know there's no operation symbol, but right there, when those two are touching, we know that means multiply. So that's an algebraic expression. Today we're going to work on simplifying them. First things first, we got some vocab that we got to learn. This vocab is super important for today's lesson. A lot of your homework is going to be about this vocab. So I have 4 big words that I need to make sure we get down. If you need to pause right now to get these down, go for that. I'm going to just kind of talk my way through them. So pause if you need to write these down. But these 4 words are big words for today's lesson. Our first one is term. A term is a number or product of a number and a variable. Example can be 12, 2x, 13y, 7. It can be a lot of different things. Basically what a term is when we write out a problem. So let's say I have 2x plus 3 plus 4y. Here's one term. Here's 2 terms. Here's 3 terms. Basically, a term is something that's separated from one another by some sort of something. But notice that 2x together is not 2 terms, but it's 1 term. 4y is 1 term. So this is 1, 2, 3 terms right there. Basically just either a number by itself or a number attached to a letter or a variable. Our constants are a term with no variable. So if we look up here at our same problem, our constant here would be 4 because we have 2x, it's with a variable, and 4y is with a variable, but 4 does not have a variable. So it's a constant. A constant are going to be your regular integers, 6, 2, negative 3, negative 8. It's just going to be your regular numbers. So in a math problem, if we had 2x plus 5, your constant right there would be 5. It's not attached to a variable. It has no variable. All right, like terms. Like terms, really all this means is that there's 2 things that have similar terms. For example, 6a and 2a. Their like terms is that they both have a. 8b and negative 7b. They're like terms because they both have b. 2x and 3x. They're like terms because they both have x. So if we had a problem that was like 2x plus 3x, those are like terms. What's important about like terms, I put a little star over here, is you can combine them. So if I have 2x plus 3x, I can make 5x. But 2x plus 3y does not make 5xy. This means does not. That does not work. Because they're not like terms. Like terms have similar variables, 6a and 2a, 8b and negative 7b. Notice that they're the same. And finally, our coefficient is a number that multiplies variables. It's the number that comes right before the variable. So in our like terms, like for example here, we have 2x. Our coefficient would be 2. 3x, our coefficient would be 3. 7k, 7 would be our coefficient. 6g, 6 is our coefficient. Negative 12r, negative 12 is our coefficient. It's the number that comes before. So I have an example down here. 7a plus 4a plus 3b minus 6. I have examples of all of these terms in here. First off, each is a term. This is a term 1. This is term 2, term 3, 4. There's 4 terms here. I just pointed them out. The like terms, 7a and 4a, they both have a. 3b is not a like term to them because it does not have a similar variable. Our coefficient, we got examples of them right here. 7, 4, and 3 are all coefficients. I know I only underlined 3, but they're all multiplied by an integer. They all have coefficients. Finally, our constant is our 6 at the end. It doesn't have a variable attached to it, a term with no variable, so we know that's our constant. Part of your work today will be determining certain things if they are a constant, a like term, a coefficient, things like that. So I got a couple practice problems for us for that. But before we get into that, we're going to try one little tip that I like to use when I am trying to solve these. So my tip is to rewrite subtraction and is adding the opposite. We worked on this last week. I think it's a super valuable tool, especially right now. That's why we worked on it last week. So for example, we have 5x minus 3y plus 2 minus 2. I can rewrite this as 5x plus negative 3y plus 2 plus negative 2. And what this is really going to do is it's going to make it easier for me to find my coefficients. It's going to make it easier for me to find my like terms, things like that. So I would recommend when we're doing these problems to try to rewrite in a way is adding the opposite. And I'll do plenty of examples with that as we go along here. So for the first one, they're asking us to find the coefficients, like terms, and constants. So I'm looking at this right away. I'm going to do what I just told you. I'm going to rewrite this, adding the opposite. So I'm going to rewrite this 3m plus 2 plus negative 2n, adding the opposite, plus n plus negative 4. All right, right away I'm going to start by finding the coefficients. I see 3 is attached, negative 2 is attached. I know there's something right here, but it's not there right now. We'll talk about that in a second. So we got coefficient 3, coefficient negative 2, and a coefficient right here, but I haven't said that yet. All we have is n, but I know that that is really the same as 1n. So our coefficient there would be 1. So look how I rewrote that. I added that 1n in there. That can help you out as well. So those are our coefficients. So I'm just going to write coefficients 3, negative 2, 1. Our like terms, right there, that's LT. Right here I see like terms. Remember, that means they have the same variable. I see n. Our like terms are negative 2n and 1n. They both have n. 3m is not a like term. Negative 4 is not a like term. They don't have anything to match it. And our constants, in this case, our constants are what are not attached to a variable. So I see that 4 is left to here. Our constant would be negative 4. Look at the next one. I don't need to rewrite this because there's already no negatives in it. So I got 6 plus 2s plus 4s. Start with my coefficients. Remember, that's the number that comes before a variable. So we got 2 and 4. My like terms, those are those variables that are the same. So I got 2s and 4s. They share a variable. And our constants are numbers that are not attached. 6. All right, one more example. We got negative 4x. This one's pretty short and simple. Let's start with our coefficients. Those are the numbers that come before the variables. We got negative 4 right here. Like terms, there's no like terms because there's only one term. Just negative 4x is our only term. And our constants, still none. Our only term is negative 4x. So there's a little practice with that. Now we're going to move into our next step that I was talking about, which is going to be simplifying these models. This is where we get a chance to put all this work together and practice what we know. So starting here, we got 2x plus 4 plus 3x. I'm going to rewrite using some of the rules that we worked on last week. I'm going to rewrite this like that. I'm allowed to do that because of the commutative rule, which we worked on last week. I can rewrite it however I want when I'm doing all addition. So I see this, and I see that I can add 3x plus 2x. These are like terms. That means I can change them into 5x plus 4. And I cannot solve that any farther because 4 is not a like term to 5x. They don't go together. 3x plus 2x works because they both share an x. This does not. It's our constant and it has to stay far away. Look at the next one. We got 3a plus 2 plus 4a minus 1. I'm going to start by rewriting as 3a plus 2 plus 4a plus negative 1, adding that opposite. From there, I'm going to move on to my commutative rule. I'm going to rearrange this how I want to. I'm going to rewrite this as 3a plus 4a plus 2 plus negative 1. I'm putting my like terms by each other right here. Oh, sorry, I got off the bottom there a little bit. I'm putting my like terms by each other right here, because I know I can add those together. 3a plus 4a, 7a plus 2 plus negative 1, leaves us with 1. We cannot connect those anymore because they're not like terms. This one has a variable, this one doesn't. Not like terms, that's how we got to leave it. All right, there's some practice on that. I got a bit more for us here. I know this lesson is a little bit longer, but we got a lot to learn. So now we're going to practice using the distributive property, another thing that we practiced last week. Look at that, it's all coming together. So we're asked to simplify 5y plus y. So I already did this one actually. 5y plus y, I rewrote as 5y plus 1y. I put that 1 in front because I know that that's the coefficient there. It's hidden, but I know that it's actually a 1 sitting right in front here. 5y plus 1y, you probably already know what that is, but we're going to use the distributive property to rewrite this. That means I'm going to take out this y. We practiced this earlier last week. Take out this y, and we're going to set it on the side and put 5 plus 1 in the middle. Now, if we look at this, remember in a distributive property, if we were to distribute it back out, it would look just like this. So I'm going to rewrite it like this, 5 plus 1y, and then finally simplify that to 6y. All right, looking at this next example, we got 3b minus b. I'm going to rewrite as 3b plus negative 1b. Change that to a 1. I know that coefficient there. It's an imaginary 1. I don't know why I just made that weird little thing. I'm going to finish boxing it off, even though it's not done yet. So that 3b plus negative 1b. I'm going to pull out the b and make it 3 plus, actually I'm going to make it 3 plus, yeah, we'll do negative 1. I know I got those doubles there, and I can rewrite that as b 3 minus 1, and I can rewrite that as b times 2 or 2b. One more example of that. We got negative 4m minus 9m. First step, rewrite that. Negative 4m plus negative 9m. Using the distributive property, I'm going to change that into negative 4 plus negative 9 times m. I took that m out, pulled it aside. Use that distributive property. Finally, negative 4 plus negative 9. I know adding two negatives is just like adding positives. Rewrite that as negative 13m. And that would be your final answer there. Let's box that last one. All right, a couple more examples here. And then we're all done with this one. Some deductive reasoning that I did. So they told me to evaluate 4g plus 9 plus 3g for g equals 5. Now, before we were just plugging this right in. But first, I want to start by simplifying. So I did 4g plus 9 plus 3g equals 4g plus 3g plus 9. I used that commutative property they've been talking about so much. Rearranged it, made it a little easier for myself. Then I used the distributive property. I pulled out that g and made it 4 plus 3g plus 9. Added those up, got to 7g plus 9. And now I plugged in that g. I brought that all the way in from there, plugged it in. I know that 7 times 5 is 35 plus 9. Final answer, 44. We got one more to try here. We're going to simplify this. We got 6y plus 4m minus 7y minus m. I'm going to start by rewriting, adding the opposite to make it 6y plus 4m plus negative 7y plus negative 1m. Remember, I put that negative 1 there because There's an imaginary 1 sitting right in front of that. Next up, I'm going to use that commutative property, rearrange this how I like. 6y plus negative 7y. I'm able to do this because I made it all addition. That's another big reason to make it all addition. You can use that commutative property. If I have the subtraction still in there, I can't use that commutative property, but once I make it all into addition, I can. So I'm going to rearrange this, put my like terms by each other. I see those like terms, those two y's, I put them by each other. The two m's, I put them by each other because I know I can't connect them with each other, but I can connect them with other y's and other m's. So that leaves us with 6y plus negative 7y. I know using my rules that makes negative 1y plus 4m plus negative 1m gets us to 3m. And I can simplify this to negative y plus 3m. And those can't connect any further because they're not like terms. And that would be our final answer. I know that was a little longer lesson. If you have any questions, feel free to email me. I know there was a lot to that. We'll get a lot of practice with this. Make sure you get these words written down right here if you haven't. Pause right there and do that. This will be our last lesson. You got tomorrow. You'll do a little online quiz worksheet deal, and then you have a little break. So enjoy that. See ya.